you two champions, welcome to day 10 of 21 days challenge to get 95% in your second PUC board exams. So as part of today's challenge, I have given you two chapters for homework. The first one is aldehydes, ketones and carboxylic acids from chemistry, and the second one is nuclei from physics. So you have to revise these two chapters and practice its most important questions from the PDF I have provided. If you haven't downloaded yet, the link is there in the description section. So please click on the link, visit the page and download the most important questions PDF and practice them at any cost. Now in this video, we will be doing a quick revision of the chapter aldehydes, ketones and carboxylic acid, and we'll see what are the important points, important reactions, important mechanisms in this particular chapter. Okay, so let's get started, and first let's understand what we have to cover in today's chapter. So first we will do about the preparation of aldehydes and ketones, then their physical properties, chemical properties, carboxylic acids nomenclature, preparation, chemical properties and the uses of carboxylic acids. Okay, so first of all, let's talk about the preparation. So the entire preparation part is divided into three categories. The first one are those reactions by which we can prepare both aldehydes and ketones. The second one is for the preparation of only aldehydes, and the third one is for the preparation of only ketones. Okay, so now let's see for the preparation of both aldehydes and ketones. We have oxidation of alcohols, dehydration of alcohols and from hydrocarbons. Now if I see for preparation of only aldehydes, I have from acyl chlorides, from nitriles and esters and from hydrocarbons. Next, in the preparation of ketones, we have from acyl chlorides, from nitriles and from substituted benzene. Okay, so first let's talk about in this from hydrocarbons, we have ozonolysis and hydration of alkynes. So now let's first talk about the from hydrocarbons, oxidation of methyl benzene, side chain chlorination and Gattermann-Koch reaction. So first of all, you need to have a clarity about this thing. So let me just repeat to you that for the preparation part, we have three important methods. The first one is preparation of both aldehydes and ketones. In that, we have the first one is from oxidation of alcohols. Next one is dehydration of alcohols, and the third one is from hydrocarbons. Under that, we have two mechanisms. One is, or I can say two ways, that is one is from the alkynes and the other one is from ozonolysis. Okay, now coming to preparation of only aldehydes, here also first we have from acyl chlorides, the second one we have nitriles and esters, the third one we have from hydrocarbons, where again we have three different methods. The first one is oxidation of methyl benzene, the second one is chlorination of side chain, and the third one we have is Gattermann-Koch reaction. Now next is preparation of ketones. For preparation of ketones also we have three different reactions. From acyl chlorides, the first one, then we have from nitriles, and then from substituted benzenes. Okay, so let's see the first one, preparation of both aldehydes and ketones. As we discussed, we have three methods in this, from oxidation of alcohols, dehydration of alcohols, and let me just tell you that these two reactions we have already covered in the chapter alcohols, phenols and ethers. Okay, and from hydrocarbons we have ozonolysis and hydration of alkynes. So first let's see before moving ahead. So children, we have very few days, hardly 75 days for KCET 2026 examination. So please remember that to crack this exam with a very good rank, to secure a seat in a top college, only studying will not help. Apart from studying, something which is very important is to write your test, to evaluate yourself and to improve yourself. And to help you with this, I have launched the Fighter KCET 2026 test series, which is designed based on the KCET pattern and syllabus by the KCET experts. And here total you will be getting 18 full length mocks, 6 from physics, 6 from chemistry and 6 from maths. And these test series, as I said, are of KCET exam level, and after the test you will also be getting the detailed solutions, and for chemistry you'll be getting video solutions. And apart from that, the most important thing is you will get a detailed test analysis report which will tell you which are your weak areas, which are your strong areas, how to prepare further. Okay, and all this is available at a very affordable price of just rupees 399, and this price is for a limited period of time. The link is there in the description section. You can definitely go and check there and can boost your preparation. Okay, now let's move to the preparation of like methods by which we can prepare both aldehydes and ketones. Here the first method was from the oxidation of alcohol, right? The first method was oxidation of alcohols. So now you remember here that if you take any primary alcohol and treat it with PCC or CrO3, for primary alcohol you will get aldehydes. Okay, and if you take any secondary alcohol, okay, and you treat it with PCC or CrO3, you will get your ketones. Clear? This is done. The second method is dehydration of alcohols. Okay, now here if you see the primary alcohol is there, and if you treat it at copper with 573 Kelvin, you will get aldehydes. Okay, from primary alcohols again you will get aldehydes, and then with secondary alcohols again at copper and 573 Kelvin you will get ketones. Okay, now the third one is from hydrocarbons, right? The third one we have remembered is from hydrocarbons. And in hydrocarbons, we have two methods. The first one is your ozonolysis. Okay, here what will happen? The bond will break like this. And once the bond will break, you can add oxygen to both the sides. And then you will get one side, like for example, if I have a propene group like this, suppose I have a structure like this, CH3, CH, CH3. Okay, one second. One of the H I will remove here. Yeah. So if I have a structure like this, and you just now treat it with ozone and then zinc and water, so what will happen? The bond will break here and you will get oxygen here and oxygen here. So this particular compound will be CH3, COCH3. Okay, and the other compound will be H. You have C, right? You have H, you have H, and you have double bond O. Okay, so that is your acetone and this is ethanol. So based on this you can get aldehydes and ketones produced. Next one is from alkynes. Okay, so here what happens, there's a method. First of all, when you treat water and H plus and Hg2 plus, then H and OH is added following Markovnikov's rule. Okay, and after that what happens, there is something called as tautomerization. Okay, now here also I'll give you an example. Suppose I have CH3, C, triple bond CH. Okay, and then you are treating it with water with Hg2 plus and H plus. Okay, now what will happen here? H and OH will be added following Markovnikov's rule. So you will have CH3, C, this side OH will come, and this side double bond will be there, and you have CH2. Now after that what will happen? There is tautomerization. So this oxygen, this pair of electrons will come here and this one will move here. Then you will get CH3, C, double bond O, and then you have CH3. Okay, so this is all about how the addition of Hg2 plus and water, first it will give you something called as enol. Okay, to triple bond if you add, means to alkynes. Now this enol then undergoes hydrolysis to give you acetone. Okay, next we'll talk about preparation of only aldehydes. So here we have the first method is from acyl chloride, second one is from nitriles and esters, and third one is from hydrocarbons. Now under from nitriles and esters we have Stephan reaction, you have using dibyl H. And from hydrocarbons we have oxidation of methyl benzene, chlorination of side chain, and Gattermann-Koch reaction. Okay, so we will see all these reactions. So first is, you can see from acyl chlorides, the first reaction here is from acyl chlorides. So you can see how I have prepared mind maps for all of them. This will really help you to revise quickly. So you have to take any acyl chloride, COCl, this particular group, RCOCl. Okay, this particular group is called as acyl chlorides. So when you take any acyl chloride and treat it with H2 palladium barium sulfate, then this chlorine is replaced with the hydrogen group to give you an aldehyde. Okay, next one is your from nitriles and esters. So see, if you have nitriles, first one is from nitriles. I'll just write down here like this, from nitriles. Okay, now if you take nitriles and treat it with SnCl to HCl, first you get a compound which is called as imine. Now this one is treated with H3O plus and that will give you RCHO. Okay, RC and SnCl to HCl, imine, and then H3O plus will give you. Now this particular reaction is called as Stephan reaction. Okay, now the same nitriles can be treated with dibyl H. There is a reagent called as dibyl H, which stands for diisobutyl aluminium hydride, and that also gives you RCHO. Okay, so this is from nitriles, and you have also from esters. Okay, now here also from esters, if I have RCOOR dash, that is esters, and you treat it with dibyl H and water, that will give you RCHO. Okay, that will again give you RCHO from esters. So from nitriles, if you take RCN, there are two ways, by treating HNCl2 and HCl. This is your Stefan reaction, and the other one is using dibyl H. Now if you have esters, from there also we can use dibyl H and we can give it to RCH. Okay, this is the two methods of preparation. The next one was, third one is from hydrocarbons. Okay, from hydrocarbons. Okay. Now, if you have methyl benzene here, CrO2, Cl2 and CS2 is there. So first of all, here a chromial complex is formed, and then when you hydrolyze it, we get RCHO. Okay, that is from hydrocarbons. The first one here is oxidation of methyl benzene. Oxidation of methyl benzene. Okay. Next is, you can treat this CHC. Okay, one second. This particular reaction is also is a name reaction, and this reaction is called as your ETARD reaction. Okay, if you take methyl benzene and treat it with CrO2, Cl2, CS2, then you get a chromium complex here, and then if you do hydrolysis, you will get benzaldehyde. This reaction is called as ETARD reaction. Now the same methyl benzene, if you take with CrO3 and anhydride, then you get a I can say a complex like this, a ester complex like this, and then that also undergo hydrolysis to give you RCHO. Okay, this is from the oxidation of methyl benzene. We have two reactions. Now the second one here is, okay, this is third one. First method, we have two methods, and the second one here is your that is side chain chlorination, right? Side chain chlorination. So here what will happen, if you have CH3, you treat it with Cl2H nu. So H3, two hydrogens are replaced with Cl. Then if you have H2O, okay, then that Cl group is replaced with OH, and then there is dehydration and we get RCHO. Now the third method here we have is Gattermann-Koch reaction. Okay, Gattermann-Koch reaction. So here we have benzene, COHCl anhydrous AlCl3 or CuCl, and that will give you RCHO. Okay, so these are the different methods of preparation of only aldehydes. Now let's talk about only ketones method. So the first one is from acyl chlorides. Okay, one more important thing I forgot to mention here. This particular reaction is also a name reaction called as Rosenmond reaction. Okay, if you have not remember now. When you take acyl chloride and treat it with hydrogen, palladium, barium sulfate, that is Rosenmond reaction. Now here also we have from acyl chlorides, from nitriles, there also we had, and the last one is from substituted benzene. This reaction we all have studied before as well. So from acyl chlorides, if you have to treat it with dialkyl cadmium. Okay, so I'm just writing here from acyl chlorides. Okay, that will give you dialkyl cadmium. So here this Cl group will be replaced with R group. Okay, now there is another method, that is from benzene. The third one that actually we discussed, from benzene. So if you take RCOCl and treat it with AlCl3, now this reaction is also, we know, this is your Friedel-Crafts acylation reaction, right? So R-CO R here. Now there is another method, that is from nitriles. Okay, if you see, the second one was from nitriles. The second method was from nitriles. So if I treat it with nitriles, what will happen? You can treat this C6H5 MgBr. So you can see Mg, this is plus and this is minus. N is minus, C is plus. So here what will happen? Minus will attach here and the minus will attach on this one. So we will have a structure like this, and then if you do hydrolysis, you will get a compound like here. You will get oxygen will be added in this double bond. Okay, now we'll talk about the physical properties of aldehydes and ketones. So alcohols have strong hydrogen bonding, so they have stronger boiling point. Then comes aldehydes and ketones, and lastly we have ethers. Now solubility here, the lower members of aldehydes and ketones like methanol, ethanol, propanol are miscible with water in all proportions because they form hydrogen bond with water. But however, the solubility of aldehydes and ketones decreases rapidly on increasing the length of the alkyl chain. Okay, so if the alkyl chain length increases, then the solubility will decrease. Next, all aldehydes and ketones are fairly soluble in organic solvents like benzene, ether, methanol, chloroform, etc. Okay. Next, we'll see about the chemical properties of aldehydes, ketones, and carboxylic acid. This is the, I can say, bigger portion of the chapter. So first we have certain nucleophilic addition reaction. Then we'll talk about reduction reactions, oxidation reaction, reactions due to alpha hydrogen, and other reactions. Under nucleophilic reactions, we have addition of HCN, addition of NaHCO3, addition of Grignard reagent, addition of alcohols, and addition of ammonia and its derivatives. Under reduction, we have reductions to alcohols and reductions to hydrocarbons. Under oxidation, we have Tollens reagent and Fellings reagent, and then oxidation of methyl ketones. Under reactions due to alpha hydrogen, we have aldol condensation and cross aldol condensation. Then in other reactions, we have Cannizzaro reactions and electrophilic substitution reaction. So first, let us start with the nucleophilic addition reaction, where we'll talk about addition of HCN, addition of NaHSO3, addition of Grignard reagent, addition of alcohols, and addition of ammonia and its derivatives. So here, if you understand the structure of the carbonyl group, okay, so this oxygen is delta minus and carbon is delta plus. So what will happen, this delta plus carbon, right? So this is electrophilic in nature, so any nucleophile can easily attack on this one. Okay, so first let us see the first reaction, that is addition of HCN. This is the first reaction, addition of HCN. So you can see Cn is the ligand here, negative part. So the Cn will attack on the carbon, OH bond is formed, and this particular compound is called as cyanohydrine. Okay, next we have addition of this NaHSO3. So here also first O minus Na plus is formed, and here OSO2H is added, and then there is, I can say, proton exchange, and here you get OH and OSO2Na. So that is what, this is your addition of I can write this one. This is the addition of, one second, addition of NaSO3. Okay, next we have addition of Grignard reagent. So in Grignard reagent, this is plus, this is minus. So minus groups attacks on this one. OMGX attacks on this one. So after that there is hydrolysis and we get an alcohol here. Now here you should remember that if you have formaldehyde, okay, in that case you will get a primary alcohol. If you have I can say any other aldehyde, okay, any other aldehyde if you have, you will get secondary alcohol. And if you have ketone group, okay, then you will get tertiary alcohol. You need to remember this. So first ho gaya second, then this is the third, addition of Grignard reagent. The fourth one is addition of alcohols, right? So first of all, here what happens, if you see oxygen is having lone pair, so it will attack on this one. So first you get a complex like this, OR dash and OH. Now this particular product is called as hemiacetal. Okay, now if you add excess of alcohol, then what will happen again, this I can say this whole group is oxidized, and then you get OR dash structure, which is your acetal structure. Okay, now when you add ammonia and its derivatives, so here what happens, this Z group, okay, Z group, sorry, this H2 group and O group is removed, and you have a product like this. So for example, if I have a structure like this, you have H2N and Z. Okay, so we have this OH2 group will be removed, and what will be the product formed here? You will have C double bond NZ. Okay, so that is what we will get. Now based on this different Z values, we have so many additions of ammonia about which we will see now. So you can see that these are all J groups. Okay, so if it is J is H, then it is an ammonia and the product formed is imine. If J is R, then it is substituted imine. If Z is OH, then it is oxime. If you have NH2, then it is hydrazone. If it is NH with a phenyl group, then it is phenyl hydrazone. If you have 2NO2 group, then it is 2,4-dinitro phenyl hydrazone. Then here it is semi-carbazide, and this is semi-carbazone. Based on different J value, you can have different derivatives of ammonia. So this is all about the addition of nucleophilic reaction, like nucleophilic addition to aldehydes. Next we will see the reactions of reduction. So we have two types of reductions here, reductions to alcohols and reductions to hydrocarbons. Reductions to alcohol we have already seen, like if you use NaBH4 you can easily reduce, but reductions to hydrocarbons can have two name reactions here, Wolff-Kishner and Clemmensen reduction. So if you see, if you take any aldehyde or ketone and treat it with LiAlH4 or NaBH4, then that is actually reductions to alcohol. Okay, reduction to alcohol. And now if you have zinc, mercury and HCl, this is your reduction. This is Clemmensen reduction. Okay, Clemmensen reduction. And when you have NH2, you get a double bond, then KOH and ethylene glycol. This is your Wolff-Kishner reduction. Okay, so these are done. These are your reactions. Next, we'll talk about the oxidation reactions of aldehydes and ketones. Here also we have three types of reaction. One is tolerance test, one is Felling's test, one is oxidation of methyl ketones. So the first one here is your tolerance test. Okay, I'm just writing tolerance test here. So you should remember that when you treat this RCOH with AgNH3 2 whole plus, okay, that gives you RCOO minus plus Ag plus NH3 plus water. Silver salt is formed here, or I can say silver precipitated is formed here. And this reaction, okay, remember here, tolerance test is given by all the aldehydes. Okay, all aldehydes will react to this. Next one is your Felling's reaction. If you treat it with copper 2 plus and 5 OH minus, you will get again salt of acid, the salt of this particular group. Copper oxide, here it is a red precipitate, and this one, that is Felling's reaction, you have to remember it is only given by aliphatic aldehydes. Okay, it is only given by aliphatic aldehydes and not all the aldehydes, means benzaldehyde will not react in Felling's test. And the next one is our methyl ketone. So if any group is having this COCH3 whole group, okay, any group containing methyl ketone group is there, then it will definitely react with NaOX. What is this NaOX? This is the salt RCOO minus, okay, and you have Na plus, and then there is a CHX3 group formed. Now if this X is iodine, then here something which is formed is called as iodoform. Okay, this is iodoform, which is CHI3. Clear? Next, we have reactions due to alpha hydrogen aldol condensation reaction. We will first see. So what happens in aldol condensation reaction? You have dilute NaOH first of all. So this dilute NaOH will be behaving as a base, and it removes one hydrogen from here to produce a, I can say, a nucleophile. Okay, so what happens here? First of all, when you treat with this one with the base, here one proton is abstracted and a nucleophile is formed, and then this one will react again with like this COH, right? So what will happen, this negative group will attack on this one, and now what compound is formed is this one, 3-hydroxybutanol, one aldol product is formed. After that there is dehydration, and then you get a more substituted alkene following Sedzeff rule, and we get the aldol condensation product, which is a beta hydroxy sorry, this is yeah, this part, this is your what, this one is when you have a enal, okay, means you have a double bond and a aldehyde or a ketone group also. Such reactions are called as your aldol condensation. Now here this can take place with dilute NaOH or barium hydroxide also. Here you can see CH3COCH3 is there. When it reacts, first of all, in this one, I can say a nucleophile is formed like this, CH2 minus COCH3, right? And now there's another compound here, two molecules is always taken, CH3COCH3. Now this one will attack on this one. Okay, and then again this product you will get first, after that it undergoes dehydration, and you get a final product like this, that is your aldol condensation product. Next we have here cross aldol condensation. It is very similar to aldol condensation, but in cross aldol condensation what we have is two different aldehydes or ketones must react. So one of the very important conditions for aldol condensation that you must remember is they should definitely have this alpha hydrogen must be present. Okay, alpha hydrogen means the carbon next to the CHO group that must contain, or the ketone group must contain a hydrogen group. As you can see here, this is the alpha carbon, here hydrogen is present, here this is the alpha carbon, here also we have the hydrogen, right? Now in cross aldol condensation we have mixed, like two different aldehydes, if they combine, there you will get four products. Suppose I have A and B, then A plus A you will get one product, B plus B you will get one product. Now A behaving as a nucleophile and attacking on B that will be one product, and B behaving as nucleophile and attacking on A, that will be another product. Clear? Now we will talk about the Cannizzaro reaction. Here the main condition is they do not have an alpha hydrogen. Okay, you see the difference here. In aldol condensation, the condition is it should have an alpha hydrogen, and in Cannizzaro reaction, the condition is it should not have an alpha hydrogen. And aldol condensation takes place under dilute NaOH, and here the reaction takes place under concentrated alkali. And here what happens, the reactant undergoes disproportionation reaction, means oxidation and reduction. So aldehydes on oxidation will give you salt of acids, and on reduction will give you alcohols. So you can see example here. I have, for example, one second. So I have formaldehyde, right? So formaldehyde will undergo oxidation to give you potassium formate, that is the salt of formic acid, and it will undergo reduction to give you alcohols. Now if you have benzaldehyde, that will give you benzyl alcohol and it will give you sodium benzoate salt. Next, we have electrophilic substitution reaction. So here we will see CHO group, you should remember, is an electron withdrawing group, and that is why it is meta-directing group. So HNO3 and H2SO4 nitro group will have the CHO group will be attached at the NO2 position. Okay, sorry, NO2 group will be attached at the meta position. Now we will see about carboxylic acid. So for nomenclature, the suffix used is oic acid. Okay, so you have formic acid, acetic acid, propionic acid. Now here these are some important names that you should remember. 2COH group is called oxalic acid. If there is one CH2 group, then it is called malonic acid. You have two CH2 group in between, that is your succinic acid. If you have 3 CH2 group, that is glutaric acid, and 4 CH2 group, we have adipic acid. Okay, now we'll see the preparation of carboxylic acid. So it can be prepared from primary alcohols and aldehydes easily, then using alkyl benzenes, from nitriles and amides, from Grignard reagents, from acyl halides and anhydrides, and from esters. So if you see, primary alcohols and aldehydes can easily give you this acids on oxidation. Okay, so this is the first method. I have total how many methods? 6, right? So the first one is from from primary alcohols. Okay, so if you take primary alcohols and treat it with very strong oxidizing agent like alkaline KMnO4, or in presence of H3O plus or CrO3 and H2SO4, that will give you acid. That's the first method. The second one, if you see, is from alkyl benzenes. So this is from second one, from alkyl benzenes. Okay, so from alkyl benzenes, if you treat it with KMnO4, KOH and H3O plus, then you will get acetic acid here. Next, talking about from nitriles and amides, the third one here, from nitriles. Okay, so RCN, if you treat it with H plus and OH minus, first it gets converted to amide group, RCONH2, and then if you treat it with H3O plus and heating, then you will get RCOOH. Okay, so this is there. After that, the fourth one is from Grignard reagent. So you can see the fourth one is from Grignard reagent. So you have RMgX plus CO2, then here you have R minus, CO2 will react, you will get first an intermediate, and then when you hydrolyze it, you will get the acid back. Okay, next was from acyl chlorides and from anhydrides. So this is acyl chlorides and this is anhydrides. Okay, so if you treat acyl chlorides with simple water, it will break to give you acids and the other group. Similarly, you know that anhydrides are made up of two acid groups, so if you hydrolyze it, that also will give you acids. Here I have ester. Okay, so acid chlorides and from esters and from anhydrides, if you hydrolyze them, then you will get alcohol acids back. Okay, so let's see a quick revision. From primary alcohols and aldehydes, you have to use strong oxidizing agent. Alkyl benzenes also strong oxidizing agent. From nitriles and amides, if you just use H3O plus, you will get. From Grignard reagent, you have to treat it with carbon dioxide. Acyl halides, anhydrides and esters has to be hydrolyzed to give you the acids. Okay, so next we'll talk about their physical properties. So they have a very high boiling point because of strong hydrogen bonding. Next, the solubility is generally higher, but if the R group increases, the solubility will decrease. Okay, that is common to most of the thing. Now we will see the chemical reactions of carboxylic acid. So just imagine a carboxylic acid like this, right? So here the reactions of carboxylic acid can be divided into 4 parts. The first one is the reaction involving where there is this cleavage of OH bond. The second one is the reaction involving where this CO bond is breaking. The third one is the reactions where this whole COH group is involved. And the fourth one is the reaction where this R group is involved. Next, we'll just discuss this one, that is cleavage of OH bond. What all reactions we have? We have acidic nature, we have reactions with metals and alkalis, and next cleavage of CO bond. In that we have anhydride formation, esterification, reaction with PCl5, PCl3 and SOCl2, and reaction with NH3. Next, reactions involving the entire COOH group. There we have reduction reaction, decarboxylation reaction, and reactions involving the hydrocarbon part, we have halogenation and substitution. Okay, so let's first discuss about cleavage of OH bond. So for cleavage of OH bond, actually if you see, we have acidic nature and reactions with metals and alkalis. So acidic nature we will discuss at the end, but here what all reactions shows that carboxylic acids are acidic in nature. So if they react with sodium metal, they give you salt and hydrogen. If they react with NaOH, they give you salt plus water. If they react with NaHCO3, that is a bicarbonate, here you will get salt plus CO2 plus H2. So these all reactions shows that carboxylic acids are acidic in nature. Okay, so that is the first chemical reaction that we have discussed. Now for cleavage of CO bond, we have four reactions: anhydride reaction, esterification reaction, PCl3 PCl5 SOCl2, and reaction with NH3. Okay, so let's see that. Okay, here one more thing you have to understand, that we have already studied in alcohols chapter also. Electron withdrawing group increases the acidity, whereas electron donating group decreases the acidity. Okay, now if you see cleavage of CO bond, we have these four reactions: anhydride formation, esterification, reaction with PCl5 PCl3 SOCl2, and reaction with NH3. So first of all, you see when the first one is here, I'm writing anhydride formation. Okay, so when you have two carboxylic acid reacting, so what will happen, this H2O will be removed and you will get an anhydride formed here. Okay, the second reaction is the esterification reaction. Okay, here what will happen, this COOH is there, right? I'm just removing one of the OH group, one of the O is extra, so here this H2O will be removed from here, and then you will get an ester formation here. Next, the third one here is reaction with PCl5, PCl3, and SOCl2. So here one oxygen is extra here. So just remember, this OH is replaced with chlorine. Okay, so you will not have this O here. So it is simply will give you RCOCl. Okay, with PCl5 you will get POCl3 plus HCl. With PCl3 you will get H3PO3. With SOCl2 you will get SO2 and HCl. Again, I'm removing this oxygen which is extra in all these products. Okay. Then the next one was the reaction with ammonia. So what happens here, ammonia behaves as a base, this behaves as an acid, so it donates an H plus, and we get first a salt like this, and after that from here there is an elimination of water and you get an amide like this. Okay, now similarly here also we get a product like this, after heating we get amide like this. Okay, next we'll talk about, so these are the reactions where CO bond is cleaved. Now we'll talk about the reactions involving the entire COOH group. So here we have reduction and decarboxylation reaction. So any RCOH group can be easily, I can say, reduced to alcohols by strong reducing agents like lithium aluminum hydride and H3O plus. Now coming to decarboxylation reaction, when you have RCOO minus or salt of carboxylic acid, and you treat it with something called as soda lime, NaOH and CaO, okay, and you heat it, that gives you RH plus Na2CO3. Okay, and this produces decarboxylation on alkali metal salts of carboxylic acids, right, undergo decarboxylation on electrolysis also of their aqueous solution and form hydrocarbons having twice the number of carbon atoms present in the alkyl group. So here if you see, here there is decarboxylation and you are just getting RH, but if you take this particular salt or the carboxylic acid salt and you do electrolysis, this is called Cole's electrolysis, here the product will be RR. Okay, twice the number of carbons you will get. Please remember this one. Next is reactions, chemical reactions involving the hydrocarbon group. So here we have halogenation and substitution reaction. So in this halogenation, very important reaction is there, whose name is very important, that is your HVZ reaction, and every year there's a high probability that you get question from this HVZ reaction. Okay, so what is done here? So here what you need to have is, this is the COH group, so this is my alpha carbon. So in the alpha carbon there has to be one alpha hydrogen present. Okay, now when you treat it with X2 with red phosphorus and water, this alpha hydrogen which is present here is replaced with the X group. Okay, and you get alpha halocarboxylic acid. Now next one is ring substitution. So COH group is a electron withdrawing group, and since it is electron withdrawing group, this is meta directing. Okay, so on concentrated nitric acid and H2SO4, NO2 group is attached at the meta position, and similarly with Br2 and FeBr3, just a minute, similarly with Br2 and FeBr3 you will get Br at the meta position. Okay, so children, this was all about the quick revision of the chapter aldehydes, ketones and carboxylic acid. A lot of reactions are involved here, but do not worry, we will be doing soon a video on the most important questions of this chapter as well. And my dear children, only 75 days are left for KCET 2026 examination, so please start your preparation and do not forget this important tool that is required for your top rank is test series. So I have launched the fighter KCET 2026 test series, which is designed according to KCET pattern syllabus by the KCET experts, and there are total 18 mocks here, so 6 each from physics, chemistry and maths, and all this is available at just rupees 399. So if you want to take the like if you want a very good, affordable and very exam relevant test series, then this is the one for you. Link is there in the description section. Do check it out. Thank you so much for watching. All the best. Stay like for this few days, no, stay very consistent and work really hard because exams are very close. All the best.